so sorry about this. I'll get it figured out next time.
No problem. It works out pretty much the same for me. The audio isn't quite as good, but I don't know if it works out as good for you or not. You don't want to have to sit there with the phone up to your ear. So hopefully you have a speaker that you can put it on so that you can lay the phone on the desk. Yeah, and then it effectively works the same as the normal way. It's just the quality isn't quite as good. All right. Let's take a pattern with this of, I know we kind of got to this third one here, solving and graphing inequalities. But before we go on, I'd like to review just a little bit every time we have a session to make sure you can do some of these others. For example, one of the things that they want you to be able to do is solve an equation for a variable that's on the other side. See this one where they say A equals B times H and they want you to solve for H? We did that one.
Yeah.
Here's another one. Here's the temperature in Fahrenheit is equal to 9/5 of the temperature in centigrade plus 32. Solve that equation for C. Step by step. Tell me what each line should be.
I think we would subtract 32 first.
Okay, so tell me what the next line is. You don't even have to tell me your strategy. Just read me what the next line should be.
Subtracting 32.
You're correct. So tell me what the next line reads.
After that?
Yeah, in other words, once you've subtracted 32 from both sides, what do you get?
X minus 32 equals 9/5.
That's what I want. When I say read the next line to me, that's exactly what I'm looking for. Now, what's the next step you're going to do to solve for C?
Divide, oh wait, you do the, like, C minus 9 times 5?
No. These are multipliers and dividers. The 9 is a multiplier, which means I got to divide by 9. The 5 is a divider, which means I got to multiply by 5. Well, if you want to do that all in one step, I'm just going to multiply both sides by the reciprocal, 5/9.
Okay.
But if I do that to the right side, I got to do it to the left side. Now, what's the right side become? So that's what we're solving for. Now let's simplify the left side if we can. We don't necessarily have to simplify the left side. And in fact, the only reason we would want to simplify, by simplifying I mean distribute this, is if 5/9 times 32 turned into a number. But it doesn't. It becomes 160 divided by 9, so it stays a complicated fraction, which means there's no need to really distribute that. And I could give that as a final answer. Okay?
Okay.
And this would be very worthwhile if they said to you, what's 100 degrees Fahrenheit equal to in centigrade? Well, you could plug in 100, but you'd still have to solve for C, right? But if I go straight to that step and I say, what's 100 degrees Fahrenheit in centigrade, I just plug in 100 here, do the math, that's the centigrade temperature. So that's why you want to be able to do this. You always want to be able to solve an equation for any variable that they show. All right.
I'm so sorry. Somebody just tried to talk to me. Could you explain the last thing that you said? I'm sorry.
Yeah. Well, I'm not sure what the last thing I said was.
Just if you were plugging in like 100.
Yeah. Let's say somebody said to you, what is 100 degrees Fahrenheit? Well, you know what that is, right? That's, today it got to be about 85. Tomorrow it's supposed to get to be 93. Well, if I said to you 100 degrees Fahrenheit is equal to what in terms of centigrade, you would go down to this equation that I've circled, and you'd plug in 100 for F. So your answer would be 5/9 times 100 minus 32, which is 68. That's what the centigrade temperature would be, whatever that number is. You want to use a calculator? Fine. I don't really care what that number is, but it shows you how you do the problem.
Got it.
Okay. So, I think you understand. Let me give you one more test. Solve that for y. What's y equal?
Multiply by 7/5 to each side.
Now, if I multiply by 7/5, notice what's going to happen. That doesn't cause anything to go away on the right side.
But I thought we were...
You got to multiply by the reciprocal. Not by 7/5, but by 5/7. In other words, I got to multiply both sides by 5/7. Remember, my idea is to get this to go away. Well, it does as long as I multiply by the reciprocal. If I multiply by the same fraction, it doesn't go away. It'd be kind of, if I multiply both sides by 7/5, I got 49/25 y. That didn't solve for much. That's what I end up with. So the whole point of solving equations is to get the right side to be just y. Not 7/5 y, certainly not 49/25 y, but y. And the way you do that, you wanted to say it, you want to divide both sides by 7/5, and that is what you're doing. You're dividing both sides by 7/5. It's just that that means the same as multiplying by the reciprocal. Right? Okay. Now, we did a little bit on solving and graphing inequalities. Let's just review that. Solve that. Next line.
Subtract 5.
Give me the next line.
So 3x equals 15, or is greater than 15.
Next line.
3 is greater than 5.
Not 3. We're not solving for 3. We're solving for x.
X is greater than 5.
There you go. Okay, now we'll make it just slightly tougher. Ignore the top line here.
Okay.
Next line.
x is less than or greater to
Okay, hold on a second. Less than or greater, that's what that means right there. Is that what you
less
mean?
than or equal to.
Okay. Less than or equal to what?
-5.
Everything was done perfectly except for one thing. When you're dealing with an inequality and you have to divide or multiply both sides by a negative number, you have to change the direction of the inequality. This is not correct. I got to turn it the other way. That's just the rule. Still -5 on the right, but this is the answer. And there's a huge difference between x being greater than -5 or less than -5. So that aspect of inequalities is what makes it different than solving equations. I'll give you another one. You think for a second. I'm going to make this extra hard. Okay? So the first thing I'm going to do.
I think you would.
What are the two things you always want to get rid of if you have them? In either an equation or an inequality?
Parentheses and.
Or denominators.
Yeah.
We don't have any denominators, so we don't need to worry about that. But we certainly need to get rid of those parentheses. So let's do that first thing, which leaves you what? What's the next line? If the only thing I'm going to do is get rid of those parentheses, what's my next line?
2x minus 5 minus 3x minus 10.
Hold on.
Greater than 0.
Close. That negative sign needs to be distributed to that term and also that term. So what's the sign on the 10 going to be?
Just
plus 10. In other words, that's what happens when I get rid of the parentheses. Always make sure, and it only matters when it's a negative sign. In other words, if that was a positive sign, then I could just drop the parentheses and everything would stay the same. But when it's a negative sign, you have to make sure you distribute it to both of the terms that are inside the parentheses. Okay? So now I've properly gotten rid of the parentheses. What's the next step?
I think you would combine the like terms.
Good. What's the next line?
I don't really know how to do that though.
Well, combine the like terms. What like terms do we have? That's a like term, and that's another like term. Combine those two for starters. What's 2x minus?
-1x.
Okay. Now let's combine these like terms.
5.
Plus 5. Need the plus sign. You can't leave it out because it's part of an expression. Okay? Now, what's the next step? I'm getting close to an answer.
Subtract 5.
Good.
So, -x, -5.
Okay. What's the last step? Divide both sides by what?
by -1.
-1. What's that leave on the left side?
X.
What's it leave on the right side?
5.
And what does this sign need to be? Greater than or less than?
Less.
Exactly. I've got to switch it around. Okay? Doesn't affect any of the other math. In other words, I still got to divide -5 by -1. It's just that it forces me to turn that direction the other way. That's whenever I've got to either multiply or divide by a negative number. That's the only time I have to do that.
Okay.
Okay? Now, let's just review one more part. Let's graph this. How do I graph that? Where do I start?
On the y-axis, would you go up 1?
Good. So I know that point is on the line. And then what?
And then you go up 2 over 1.
Up 2 and to the right 1.
Yeah, sorry.
Over doesn't quite get it because it could go over to the left. And that would give me a negative slope. So it's very important that I end up with a positive slope, right? And that's really all you need to know. Don't get confused by up and over or down and over, because I could have just as easily gone down 2 and left 1. I would have still had a positive sloped line. Now, the last thing I got to decide is this a solid line or a dotted line?
A dotted line.
Right, because it's greater than only. It's not greater than or equal. If it was greater than or equal, it would be a solid line. And that's the only difference between a dotted line and a solid line, is whether your original thing says either the greater than or the greater than and equal. Now, the last thing to do is shade the correct side of this thing, because it doesn't say y equals 2x plus 1. It says y is greater than 2x plus 1. So which side of that line do I shade?
So left side.
Never say left or right. Always say top or bottom.
Top.
Correct. Now notice the top is the same as the left. But there's a reason I say to do that. It's because you only care about one point, the y-axis. We are not concerned about the x-axis. The x-axis measures left to right. The y-axis measures up and down. Well, that thing says y is greater. So all I got to do is go to the y-axis, find a point that's greater than that line, and that tells me which side to shade. And you can kind of get in trouble using left and right, and I'll give you an example. There's the inequality. There's where I start at 1. I have a slope of negative 100, and it's a solid line. Which side of that line do I shade? Don't use the words left or right.
The bottom.
Correct. I go to the y-axis, I find a point below that line, and it doesn't matter where, I could pick that point, that point, that point. They all indicate the side to shade. It looks a lot like the left side, but it's actually the bottom side. And like I said, it can get very confusing if you think of this in terms of left and right. You don't want to do that. You always want to look to the y-axis. Figure a point on the y-axis that fits this inequality, and that tells you which side to shade. All right. Identifying functions. I'm going to draw some functions, and you tell me which ones are functions and which aren't. Just say yes or no.
I don't know the difference, so.
Okay. There's a very simple test to tell whether a function is a function, and that's called the vertical line test. If I pass a vertical line, no matter where I pass it on that function, I can go anywhere I want, and every time I draw a vertical line, I only get one y value. I get this one, I get that one, I get that one, I get that one. You see what I'm saying? I never get two y values. That's called passing the vertical line test. And that is a function. As opposed to that. Notice that that does not pass the vertical line test. If I pass a vertical line, I get two y values. I get one there and one there. The definition of a function is that for a given value of x, you only always get one value for y.
Okay.
So that's not a function. So let me give you some other examples. Yay or nay?
Nay.
Good.
Yay.
Good. It's a vertical line.
Nay.
Correct. Because for this value of x, I got the same value. I got that value for y, I got a different value for y, I got a different value for y, I got a different value for y. So a vertical line definitely does not pass the function test. What about this line? What about that line that had a slope of negative 100?
Yeah.
Good.
Yay.
Good. One more.
Yay.
Good. You got it figured out. What's a function and what isn't. All right. Domain and range of a function. This is actually pretty easy, even though it gives people a lot of trouble. Domain is all the possible values of x. What different values can I put in for x there? And the correct way to think about domain isn't what values can I put in, it's are there any values that I cannot put in? Domain is much more about figuring out what you can't use rather than what you can use. Is there any value of x I cannot use?
Any number less than 1?
No. There's no problem if I plug in a number less than 1. I could let x equal minus 100. Then y would equal minus 99.
I think there's no number.
You're right. And the way you refer to it, there's 2 or 3 ways to refer to domain and range. I'm not sure what you've learned. Have you learned something called interval notation? If I were to write this in interval notation, that's what the answer would look like. Negative infinity to positive infinity. I could also write it this way. The domain is all reals. I could also say x less than infinity and x is greater than negative infinity, which is another way of saying this. Sometimes there's 2 intervals on these, and so they've come up with interval notation so you can list each interval and stick a U in between it. Have you seen anything like that?
Yeah.
Okay. So I'll refer to interval notation from now on. Now, some functions do have restrictions. It's the domain of this function. Remember, always be thinking, what can x not be? Not so much what can it be, but what can it not be? It's the first commandment of mathematics. Thou shalt not divide by 0. If you were to do a Google search when we're done, and you were to type in 10 commandments of mathematics, you'd get 20 different lists. Every one of them would begin with thou shalt not divide by 0. That is the foundation of mathematics. You absolutely cannot divide by 0. But there's nothing else that gives you problems. I can divide by a negative number. I can divide by a big positive number. I can divide by a fraction. The only number I cannot divide by is 0. So if I were to write the domain in interval notation, well, I'm going to go from negative infinity to 0, but I can't use 0, in combination with 0 to positive infinity. In other words, I could also write that as x is a member of all reals except x cannot be equal to 0. It's another way to write it. You see why both of those answers are the same?
Yes.
Okay. Another way to write it is x has to be greater than 0 or x has to be less than 0. That says the same thing. That says all reals except 0. Okay.
Yeah.
Go ahead.
Could you remind me what the U means?
Can I remind you what the what means?
The U.
That's in union with. In other words, when I wrote it like this, that means this interval and this interval. And notice those two intervals go from negative infinity to 0, but not counting 0. And then they go from 0 to infinity, but not counting 0. So this says the same as that. It also says the same as that. So any of those three things tell you the domain. And which we use kind of depends on where you're at in algebra. Not all Algebra 1 students get taught interval notation, because usually there's only one interval. There's not multiple intervals. In this case, there happen to be two intervals. I look at my number line. I mean, x can be any number in that direction, and it can be any number in that direction. The only thing it can't be is right there. So you have a union of that interval, u of this interval. That's what the u means. Now, more domain. Domain's pretty easy, because domain is really all about figuring out what x cannot be. Well, here's a pretty common function. You're familiar with this function. What can x not be here?
Zero again?
No, you can take the square root of 0. You can also take the square root of any positive number. But can you take the square root of a negative number?
No.
So x has to be greater than or equal to 0. So I can write that in numerous ways also. There's one way to write it. Another way to write it in interval notation is from 0 to positive infinity. And that'd be the only two ways you'd want to write this one.
Okay.
The bottom one is interval notation. The top one is just, a lot of times this will be all you get taught in Algebra 1. So I don't really want to get you into interval notation if you haven't been taught it. But might as well teach it to you if you haven't been taught it. Now, let's look at a slight alteration. Remember what the last one was. The last one was this, and the domain was x had to be greater than or equal to 0. Well, what's the domain in this one?
I have no idea.
Well, start with this. You know that you can't take the square root of a negative number, so there's no way x can be negative. So it looks like the same domain. It looks like x still has to be greater than or equal to 0, only can x be equal to 0 in the bottom one? What would that cause us to be doing? If x were 0, what would we be doing with that function? We'd be dividing 1 by what?
0, and you can't divide
So,
by 0.
x can't even be equal to 0. So in the bottom one, the domain is slightly more restrictive. X has to be greater than 0, not x greater than or equal. So they're a little different. Okay, let's keep going. More domain stuff. What can you say about what's inside the radical? You know what I mean when I say the radical sign, right?
Yeah.
Okay, so what's inside the radical is x minus 2. What can you say about x minus 2? What has to be the case?
I'm not sure.
Can you take the square root of positive and negative numbers?
No.
You can only take the square root of positive numbers or 0. So we're going to take what's inside the radical and we're going to force it to be greater than or equal to 0. That's what has to be true. Okay, and now we're going to solve that inequality. Give me the solution to this inequality.
X is greater than or equal to 2.
There's your answer. That's the domain. And again, if I wanted to write that in interval notation, I would write it like this. The only, wow, why does that thing keep disappearing? The only difference is in this case, instead of a parentheses, I use a bracket. When I'm writing it in interval notation, brackets and parentheses don't mean the same thing. Parentheses are always used next to an infinity sign, but the difference between a bracket and a parentheses here is if I use a bracket, it means x can actually be equal to 2. If x were not, in other words, if my answer was this, x had to be greater than 2 only, then I would have used a parentheses there. That's the difference between parentheses and brackets in interval notation. Another one. Remember what your thinking needs to be. What can x not be?
0.
Well, no. X could be 0. You just can't divide by 0. So what equation can I write? X minus 3 is what cannot be equal to 0, correct?
Yeah.
Which means x cannot be equal to 3. Now, I know you're not particularly used to solving non-equations, but that's how you do it basically. In other words, you know that you cannot divide by 0. Therefore, I take whatever that is, set it equal to 0, solve it, and that's what x can't be. And that's the only thing that x can't be. X can be all real numbers. So in interval notation, it's minus infinity to 3 with parentheses in combination with 3 to positive infinity. And I use parentheses in all 4 spots because x cannot be 3. If x were 3, I'd be dividing by 0. Okay, so that is domain in a nutshell. Give me domain on this.
It can be all real numbers.
Good. Now let's talk about range. Domain is all about what x can be. Range is all about what y can be. In this example, what's the range? And again, you kind of want to think, well, is there anything y can't be? Can I make y anything? Could I make y minus 10,000? Well, with an appropriate x, yes, I could. Could I make y minus a billion? Yep, I could find an x that makes y minus a billion. Can I make y plus 10 billion? Yep. In other words, the range is all real numbers for y. There is no value. Can I make y 1.5? Yes. I can make it a fraction. I can make it any fraction you want. So range is a little more difficult than domain just because it's a little harder to figure out. Are you familiar with this function? Look familiar at all?
Yeah.
It's quadratic. It's the most elementary function for a quadratic. And quadratics always look like parabolas. That's what I've tried to draw over here as a parabola. Okay? Now, another way to look at domain and range, first of all, let's look at this algebraically. What's the domain?
All real numbers.
Yeah, and now let's look at it graphically, why that's true. It's because even though I haven't drawn the end of that, the fact is that that thing goes to both infinity on the left and infinity on top. Same thing with this. Okay? So that's why it's all real numbers. Hold on a second. TV came back on. You know, when you put it on pause and it unpauses itself after 45 minutes. So
Yeah.
I can look at this graph and I can tell that my domain goes to negative infinity in that direction and it goes to positive infinity in that direction. In other words, I can put any value I want for x and I can see it graphically. Now, let's talk about range. Look at the graph and tell me what are the possible values for y, looking only at the graph.
Any real numbers still? Because like any positive numbers?
Can y be negative? You see any negative y's on there?
No.
So y can't be negative. Can y be 0?
Yes.
Okay. So it looks to me like y has to be greater than or equal to 0 according to the graph only. Otherwise, I don't see any negative y's. Now let's go back up and look at it algebraically. There's a reason y can only be positive. It's because even if you have a negative value for x, when you square it, it turns positive. In other words, if I want to know, if I say, well, let's let x be minus 3, and I square that, well then y equals plus 9. So no matter whether x is positive or negative, y is always positive or 0. So in this particular function, the range is not all real numbers. The range is greater than or equal to 0 only, whereas the domain is all real numbers. And with pretty much all quadratics, the domain is always all real numbers. Whenever you see a parabola like this, the domain is all real numbers, and the range is wherever the vertex is and above, or if it were a parabola that looked like that, then the range would be from there or below. Okay?
Okay.
Give you another one. How would I graph it?
You would go...
It's a parabola whose vertex is where?
Up 3 and then, like...
That's the vertex. Now does it open up or does it open down?
Open up.
Because the coefficient of the x term, the coefficient of the x squared term is positive, that's why it opens up. If it were negative, it would open down. What's the domain of that?
All numbers greater than 0.
No. All reals. When you're looking at the domain, train yourself to look horizontally. We're looking, well, I'm going to look. Is there any value in that direction that x can't be? No. Is there any value in this direction that x can't be? No. X can be anything. X can be 0, x can be 1, x can be 1,000,000, x can be minus 1,000,000,000. So like I said, when you're dealing with parabolas or quadratics, the domain is almost always all reals. I can't even think of one where it would not be all real numbers. Range is a different story. Now when you're looking at range, look vertically. We want to look in this direction and we want to look in this direction. Now tell me what y can be or cannot be.
It can't be any negative or 0, so.
Okay.
It has to be,
That number right there is 3. Just give it to me as a y greater than or equal or less than or equal or greater than or less than. Don't worry about interval notation at the moment. What does y have to be when you look at that graph?
y is greater than 0.
Not 0. Can y be 1?
Or 3.
Ah.
So,
Y can't be 1, y can't be 2, y can be 3, and y can certainly be any value up there. You can see there's values for y. Everywhere else I look, there's values for y. So y has to be greater than 3. Is it greater than or greater than and equal to?
Greater than and equal to.
Yeah, I need that. In other words, y can be 3. Y is exactly 3 when x is 0. So you want to be able to do these domain and range two different ways. You want to be able to do them algebraically. In other words, you want to be able to figure out domain and range from the function, but it's actually the easier way is if you have a graph of the function. If you have a graph of the function, you just have to train yourself to look at it horizontally and vertically. Give you another one. Hyperbolic function. What's the domain? What's the range? And incidentally, this function is 1 over x. That's what that function is. It's the domain. We did this one already. We just didn't do it graphically. We did it algebraically. What
the
can...
domain is anything, wait, no, it can't be 0?
All real numbers except 0. All reals except x cannot be 0. Now let's look at the range. Can you read the range from the graph? Look vertically. Look up and down. What values do you see for y? Well, same answer. Notice, whether I'm looking up here on the left, is there any way to make y 0? No matter what number, you can't put in x for 0. That wouldn't make y 0 anyway. It would make y infinite. But any other number you put in for x, no matter what it is, y is not going to be 0. It's impossible to make y 0. So I end up with asymptotes. You familiar with that word?
No.
Really? Asymptotes are places on the graph that the function can never cross. In other words, this function never crosses the x equals 0 line, that vertical dotted line, and the function never crosses the line y equals 0, the horizontal dotted line. And this is called hyperbolic in nature because x is in the denominator and you end up with asymptotes that are not crossed. But again, you can read both the domain and the range by merely looking at the graph, even if you didn't know what the graph was. In other words, if I erase this function over here and I say, what's the domain? Well, if I'm looking horizontally, I clearly can go all the way to negative infinity in that direction. I can go all the way to positive infinity in that direction. The only thing I can't do is get across this point right here. So the domain is all reals except 0. And now, if I want to look at it vertically to figure out the range, same exact thought process. I'm looking vertically. Clearly, I can go all the way to infinity vertically in that direction. And clearly, down here, I can go all the way to negative infinity in that direction. The only thing I can't do is get across that point. In other words, I cannot make y 0, ever. Not with this function. Okay? Now, it's actually been a pretty good session. It doesn't look like we've gotten very far, but I think we've covered some very important stuff. And the third part, I believe we've done numerous times. Graphing linear equations. What's linear equation mean?
It means that
It's a straight line.
straight line, yeah.
A parabola is not a linear equation. It's a quadratic equation. A linear equation usually has the form y equal mx plus b, or something like y equal 2x plus 1. Well, how would I graph that? Where would I start?
Go up 1 on the y-axis.
So there's one point that's on my line.
And then go up
And the reason that is
the
definitely on the line is because that's where x equals 0. Notice that if I plug in x of 0, y equal 1. So the y-intercept is always where x is 0. And now I get my second point by doing what?
Going up to and over to the right one.
Perfect. And I don't even pay any attention whether it's right or left. What I make sure is that when I'm done, I'm looking at a positive slope. If I'm looking at a positive slope, then I've done it correctly. In other words, I could also do this. I could go down 2 and left 1. Well, that gives me the same line. Same exact line. So it doesn't really matter whether you go up and over or down and over, as long as you end up with the right slope. In other words, if I would have ended up with that line, I've made a mistake because that has a negative slope on it.
Okay.
pick it up next time with this fourth part here. Writing a linear equation using 2 points. That's actually pretty easy also, but we're at the end of the hour. Now, did we move it, did we do an hour tonight so because we're not doing Friday at all?
Yeah.
Okay, so let me...
I'm camping this week.
Yeah, that's fine. Let me just erase Friday's session. Now, I don't know if your dad knows it or not, but he can go onto my website and schedule completely on his own. He doesn't need to have an email conversation with me to schedule a session. In other words, if he goes into my website, it shows my complete availability. He could have scheduled 7:30 to 8:30, completely on his own.
Okay.
Okay? Same thing with you. You can do the same thing. So can your mom. And you can do it on either of my websites. If you're using Digital Math Tutor, do it there. It's a little easier. If you're using Algebra to Calculus Tutor, do it on that one. But it's in the summer, it doesn't much matter because I got tons of availability. But in the wintertime where my availability is, you know, splattered throughout the day, then it's really helpful for scheduling to be able to go in there and see my availability and pick a time. I don't really care. He's welcome to do it any way he wants. Wants to do it by email, that's fine. It's just that I figured he probably didn't know that he could do it online when we had our little email exchange this morning. Okay? Well, enjoy your camping. Where about you guys headed? Do you know?
It's about, it's kind of near Glenwood Springs.
Oh.
I forgot the campsite.
Okay, up into the Rockies. That's always pretty.
Yeah.
Yeah, that should be fun. Well, enjoy, and I will talk to you next time. I will leave it to your dad to either schedule next session or you don't want to, do you want to make this Monday night permanent? You want to talk to him first?
Yeah, I'll talk to my parents about it and then we'll see if we'll make it permanent.
And I can always make it permanent if you want anytime, or it's half, you know, it's half a dozen of one, six of the other as to what's easier for you. Probably the easiest way is to go in and schedule it online whenever you want a session. Although there is a certain advantage into having one that's just automatically at 7:30 every Monday night, you know. But I'll let you guys figure that out.
Well, thank you.
You're welcome. Have a good week. Talk to you next week.
All right.
Bye-bye.
See you later.
Bye.
Bye.